Hello everyone, my name is Pranit. Today I will be presenting my assignment for the course Human Factors in AI. So the context of this assignment is that we are focusing on reducing the energy consumption for the HVAC systems. So, so the context here is that basically HVAC system stands for heating, ventilation, and air conditioning equipment. These HVAC systems consider sensors like temperature, wind, and to track air quality. It is also presented that in 2020, HVAC system consumed around 36% of global energy. So it takes a lot of energy uh, from what we generally generate. So that is the problem that we need to look into. So what's the opportunity here? So looking into the opportunity evaluation, the problem statement that we have is that HVAC systems in offices are used below and above their individual capacity. So because of the inadequate use of the HVAC systems, this lead to inefficient energy use and therefore lead to costly energy bills for house owners and as well as for offices and enterprises. Now looking to the task analysis, uh, what triggers for the user is that high electricity bill, which leads to taking the action that he used to track usage of the SVC systems and take decision that whether to switch off the AC or to reduce the temperature of the AC or not. In case if he has switched off the AC, then he need to switch on the AC again if it is required. And the overall objective of this problem is to reduce the electricity bill that a particular user has. Now, focusing on the user experience design, we have generally taken the user input, taking the room size, like its length, breadth, the number of windows which he has in a particular room, what's the direction of the window, and number of AC units that he has in that particular room with the weight of that particular AC as well. Like there is an AC for 1.5 ton and there is one AC for 1 ton. So that is what we have taken from user. One also thing that we have taken from user is like what's the tariff rate that he has in that particular area or in his city, and for how long he is using the HVAC system in his room or the office. Based on that, we are presenting the data on the dashboard section where we are basically picking up the data from like the weather report like wind speed, humidity, what's the precipitation rate which the user has in his city as of now. So this data has been collected from windy.com, which is mentioned here. We are also sharing the data about the daily energy consumption which user will have in his room or office, like what's the how many units that he will going to consume by that particular HVAC system and what will be the rate that he need to pay for that particular day. So based on the model that we have, we are building a recommendation system which will tell the user that whether he can switch off the AC or not in a particular room, and so that he can reduce his energy consumption, and which will lead to reduction in the bill. This is what the analytics section will be like, where he can see that by the red mark will show here that what will be the energy bill if he has not used our recommendation system, and what will be the energy bill if he has used our recommendation system. Now, using this basically this analytics section, we have maintained the transparency and communicating uncertainty, where the uncertainty is communicated through, where we have mentioned is that the saving will be around $100 to $150. We have not provided the exact number, but we have provided the range which the user can get after applying our recommendation. And one more thing that we have specified here is that the red line basically recommends that this is without the recommendation, and the green is on recommendation. Now, looking at the privacy considerations, basically we are collecting the financial data. So financial privacy is something that we are looking for, which comes into Gramm-Leach-Bliley Act of 1999. And the privacy rule which we need to go through is opting out the data that which we cannot share it externally, right? And uh, how we can safeguard this rule is like putting all the administrative, technical, and physical safeguards so as to ensure the confidentiality of the customer data. Now, looking at the ethical considerations, uh, basically two biases that we think that can take place in this particular model is learning bias, where modeling choices may amplify the performance disparities, and the deployment bias, where mismatch between how a tool was intended to be used and how it is used in practice. Like maybe we have built a model for some purpose and it is giving results as per some other criteria. So that is the deployment bias that we think may come in the future. So ethical considerations that we have is fairness, accountable, and transparent. Fairness is like we have considered both businesses as well as individual houses, like taking care of all the groups of users. Accountability is like taking responsibility of the outcome, the predictions that we are making in our model, and we are providing transparency by giving users the flexibility of choosing the features. So that is what this is all from my end. I hope you have liked it. Thank you very much. In case you want to connect with me, you can look into my LinkedIn profile. Thank you. Bye bye.